Hi everyone, I'm Dr. Koenig, and this is a quick video tutorial on order of operations, specifically focused on integers. So let's start with what is the order of operations. Many teachers have different ways to help you remember the order that you should solve a problem, but there is a standardized way that we as a culture have accepted that is the way to solve a math problem that allows us all to get the same answer at the same time. It's a general rule that we follow. Now, the way I prefer to remember the order of operations is to remember PEMDAS. PEMDAS is an acronym where every letter stands for something. The first letter in PEMDAS is P. It stands for parentheses. When we're looking at a problem, we want to solve for parentheses first. Now, for parentheses, what we really mean is that we want parentheses with math on the inside. So this would be speaking to, let's say, -6 plus 7 would be parentheses. But if you see like -2 parentheses 5, all that's telling you is to multiply. That's a different step in order of operations. However, if you have parentheses like these with a math problem on the inside, that's your first step. The next step is to look for exponents. If you have exponents in the problem, you'll recognize them because they're kind of to the top right of another number. Often we see the 2. And what that means is whatever's there, let's say it's like a 5, I need to multiply it by itself however many times that exponent tells me. So that would mean I need 5 times 5, which of course is 25. If instead I had, let's say, a 3, that would mean that I need to take the number inside the parentheses and multiply it by itself 3 times, and in this case I would get 8. That's exponents in a nutshell. Now, exponents comes right after parentheses. So first we find any math problems that fall inside parentheses, then we look for exponents. Next, we have multiplication and division. You'll see that I put them up together and that I put a bracket around them. And that's because multiplication and division have the same level of importance when it comes to solving a problem. Once we have solved the things inside parentheses, once we've looked for exponents, we get to multiplication and division. And we solve any multiplication and division pieces in the problem together at the same time. We go from left to right. That's how we know which ones to do when. Last, we have addition and subtraction. That's similar. They're the same level of importance in order of operations. So once we've done parentheses, exponents, multiplication and division, then we look at addition and subtraction. That's the last step in order of operations. And again, we go from left to right. So we don't necessarily have to add first. We do necessarily have to go from left to right, solving whichever one shows up first in the problem, and then moving on to the next one. Let's take a look at a few problems so we can really get our brains around the order of operations and how we should solve. So I'll start by putting PEMDAS at the top of my paper. I don't always, but it does help while you're learning to really focus your mind on what should happen first, what should happen next, and so on. Now the first letter, of course, is P for parentheses. I see that I've got parentheses, and those parentheses aren't just there for no reason. They have a math problem on the inside. That's exactly what that P for parentheses is for. So that's the first step. I need to take -5 and add to it 3, and I know that that gives me -2. You'll notice that I'm keeping the parentheses. I haven't gotten rid of them, and that's because in the original problem, this -4 was right up next to the parentheses, which means the -4 is going to end up multiplied by whatever we got in those parentheses, in this case, -2. If I didn't put parentheses, I would have -4, -2, and that would look an awful lot like -4 minus 2, which is not really what this problem is going for. Now that I've finished my parentheses, I can tell that there are no exponents in the problem, and we just discussed there is some multiplication. Now -4 right next to the parentheses, again, means -4 is being multiplied by -2, and I know that -4 times -2 is 8. At this point, I have no more operations left, no division, no addition, no subtraction, so I am done with my problem, and the answer is 8. Let's try another, a little more tricky. Now, again, I'm going to start by writing PEMDAS up in the top right corner. That helps me to identify what I should do at any given time. Now, I do see parentheses. However, do you notice that inside these parentheses, there's just one number, a -4 or a -5? There's not an operation. There's not something we have to do with that number. That tells me that I can actually skip the parentheses step. Those parentheses are there for a different reason. Now, this time, I do have an exponent step. So I have -4 to the power of 2 and -5 to the power of 2. So I need to solve those first. Now, negative 4 to the power of 2 means I need negative 4 times negative 4. Negative 4 times negative 4, I know, is 16. Same thing happens for the negative 5. I have a negative 5 times another negative 5, which I know is positive 25. Now I've solved my exponent step. I am going to bring down the minus sign all the way down into my problem. I can see that there is no multiplication, no division, no addition. So I'm going to skip these 3 steps and go straight to subtraction. I do have subtraction in this problem. And I know that 16 minus 25 is negative 9. Moving on, here's another quick problem with order of operations. Again, I'm going to write out PEMDAS. I did want to show you this specific problem because it's a little different in that there are brackets. Brackets make the problem look a little more intimidating. What they really are is parentheses. Sometimes when we're already using parentheses, like you'll see right here, we'll use brackets if we need more parentheses so that you can tell what matches with what. So I can tell that my parentheses go together and I can tell that my brackets go together. Now that I have that information shared, let's jump into solving. Now, I'm going to treat these brackets as my P for parentheses because inside those brackets there is something to do. Inside these parentheses, there's just a number. So that means it's not really a problem to solve, so those aren't the parentheses I need to focus on. Now, when I'm solving those brackets, I have a negative 3 right next to a negative 3. That means these two negative 3's are being multiplied. And if I multiply them, I will get a positive 9. And then I'll bring down my negative 18 and my divided sign. From here, I can tell that the only remaining operation is division. So, of course, that's my next step. Negative 18 divided by negative 9 is negative 2. This example is a little different and a prime example of why the order of operations matters. Now, the order of operations tells us to do parentheses, exponents, multiply and divide, add and subtract. And if you look closely at this problem, your 2 operations are to divide and to add. So in this problem, we have to do the division step first. It's really tempting to go from left to right on all of these problems. It would be much easier to go from left to right. However, that goes against the order of operations. In this case, we have to divide negative 18 by negative 6, which gives us a positive 3. From there, we bring down the other 3 and the plus sign, and we can add 3 and 3 to get 6 as our final solution. Interestingly enough, if you did take that from left to right, you would add 3 plus negative 18, which would give you negative 15. And then when you divide by negative 6, you would get 2.5. Now, that's not a problem. You can do order of operations problems and get a fraction or a decimal answer, but here we're really working on using the order of operations with integers, so that would be a good sign if I got a 2.5. That would be a good sign that I did something wrong. In this problem, we can't go from left to right. We have to divide first, then we can add. Here's another example where it's really tempting to go from left to right, but following the order of operations, I'll look first for parentheses. There are a lot of parentheses, but none with a math problem on the inside. They all just have a single number. So those parentheses are there for a different reason. I don't see any exponents, but I do see multiplication and division. So my first step here would be to identify where that's happening. Now, I find it really helpful to circle and focus on certain things at a time. You might use a highlighter, you might circle, you might underline, colored pen, something like that, but having a strategy in place can be helpful. In this case, I see where my multiplication and division is, so I'm going to solve those from left to right. Negative 2 times 4 I know is negative 8. Negative 3 times negative 5 is, of course, 15. And then negative 6 divided by 2 is negative 3. I will put these negatives in parentheses just so I don't confuse those negatives as minus signs. Then I can bring down the stuff that's left. I have a plus sign and I have a minus sign. From here, all that's left is addition and subtraction. Now I can go from left to right. First, I'll solve negative 8 plus 15 to get 7. And then I bring it down and I see that I have 7 minus negative 3. Now in my class, we have learned to add the opposite, add the additive inverse. So we're going to change that minus a negative 3 to 7 plus positive 3, and that gives us a result of 10. So the big idea with order of operations is that we use PEMDAS. It's a standard way to solve any problem, any math problem, so that everyone who solves it should get the same answer, and it's uniform and expected. First, parentheses, then exponents. Remember, multiplication and division happen at the same time. You just solve whatever multiplication and division you get from left to right. Same goes for addition and subtraction. They happen at the same time. You solve them from left to right. I hope this video gave you some strategies to pull from when you're solving order of operations with integers. As soon as you throw negatives into a problem, it gets kind of tricky, and so it's great to regroup and refocus on what is the order of operations and how do I use it when there are integers in the problem. Thanks for being here, and I'll see you next time.